Without a reference to column 3, I cannot definitively say whether it pertains to Schedule 40, Schedule 80, or both PVC conduit types. However, I can provide a general overview of these two common PVC conduit schedules. Firstly, let's examine Schedule 40 PVC conduit. Schedule 40 PVC is a type of thermoplastic conduit widely used in electrical applications. It's manufactured to specific dimensions and wall thicknesses according to industry standards. The primary use for Schedule 40 PVC conduit is to provide a protective pathway for electrical wiring. This protects the conductors from physical damage, moisture, and corrosive environment. Schedule 40 is suitable for direct burial applications, meaning it can be installed underground without additional protection. However, local codes and regulations should always be consulted to ensure compliance with burial depth requirements and other specifications. Schedule 40 PVC conduit is commonly used in residential, commercial, and industrial settings. Typical applications include branch circuits, feeders, and service entrances. It's frequently used in exposed locations, such as along walls or ceilings, and in concealed locations, such as within walls or underground. The bending of Schedule 40 PVC conduit is achieved through the use of heat. Electric benders or hot boxes are typically employed to soften the PVC, allowing it to be shaped to the desired angle. It is crucial to maintain a consistent bending radius to avoid kinking or collapsing the conduit. Proper bending techniques are essential for ensuring a professional and code-compliant installation. Schedule 40 PVC conduit is joined together using PVC solvent cement. This cement chemically welds the conduit sections, creating a watertight and durable connection. It's important to use the correct type of cement and to follow the manufacturer's instructions for proper application. Cleanliness is essential for a strong bond. The surfaces to be joined must be clean, dry, and free of any debris. Secondly, we will look at Schedule 80 PVC conduit. Schedule 80 PVC conduit is a heavier walled version of Schedule 40. This increased wall thickness provides greater physical strength and resistance to impact. As a result, Schedule 80 is suitable for applications where greater protection is required. This type of conduit is often chosen for locations where the conduit may be subjected to mechanical stress or potential damage. Schedule 80 PVC conduit is commonly used in industrial settings, particularly in areas where heavy machinery is present or where there is a risk of impact from moving equipment. It is also preferred for direct burial applications where soil conditions are aggressive or where there is a high risk of damage from digging or other activities. Because of its thicker walls, Schedule 80 PVC conduit offers improved resistance to crushing and deformation compared to Schedule 40. This makes it a better choice for underground installations where heavy loads may be applied to the conduit. Schedule 80 PVC conduit can also be used in exposed locations where greater physical protection is desired. For example, it may be used to protect wiring in areas where there is a high risk of vandalism or accidental damage. The bending of Schedule 80 PVC conduit is similar to that of Schedule 40. However, due to its thicker walls, it may require more heat and a longer bending time to achieve the desired angle. It is important to use the correct bending equipment and to follow the manufacturer's instructions carefully. Schedule 80 PVC conduit is also joined together using PVC solvent cement. The same principles of cleanliness and proper application apply as with Schedule 40. It is important to ensure that the cement is compatible with Schedule 80 PVC and that it is applied according to the manufacturer's instructions. In summary, the key difference between Schedule 40 and Schedule 80 PVC conduit is the wall thickness. Schedule 80 has a thicker wall, providing greater physical strength and resistance to impact. The choice between the two depends on the specific application and the level of protection required. When selecting PVC conduit, it is essential to consider the following factors. Firstly, the environmental conditions. The conduit must be suitable for the temperature, moisture, and chemical exposure of the installation environment. Secondly, the physical protection requirements. The conduit must provide adequate protection against physical damage from impact, abrasion, and crushing. Thirdly, the electrical code requirements. The conduit must comply with all applicable electrical codes and regulations. Fourthly, the cost. Schedule 80 PVC conduit is generally more expensive than Schedule 40. The total cost of the installation should be considered when making a decision. The National Electrical Code, or NEC, provides guidelines for the use of PVC conduit in various applications. It specifies the types of conduit that are permitted for use in different locations and under different conditions. It also provides requirements for the support and securing of conduit, as well as for the installation of fittings and connectors. When installing PVC conduit, it is important to follow all applicable NEC requirements. This will help to ensure a safe and code-compliant installation. Some common NEC articles that relate to PVC conduit include Article 352 covering PVC conduit, Article 300 covering wiring methods, and Article 310 covering conductors for general wiring. These articles provide detailed information on the proper installation and use of PVC conduit. Regarding conductor fill, the NEC specifies the maximum number of conductors that can be installed in a given size of conduit. This is to prevent overheating and to ensure that the conductors can be easily pulled through the conduit. The conductor fill requirements vary depending on the size of the conduit, the type of conductors, and the number of conductors. It is important to consult the NEC to determine the correct conductor fill for a specific installation. The ampacity of conductors installed in PVC conduit is also affected by the conduit's properties. PVC conduit is a non-metallic material, which means that it does not conduct heat as well as metallic conduit. This can lead to higher conductor temperatures, which can reduce the ampacity of the conductors. The NEC provides ampacity adjustment factors that must be applied to conductors installed in PVC conduit to account for the higher temperatures. These adjustment factors vary depending on the number of conductors in the conduit and the ambient temperature. When selecting conductors for use in PVC conduit, it is important to consider the ampacity adjustment factors and to choose conductors that are properly sized for the application. In addition to the NEC, local codes and regulations may also apply to the installation of PVC conduit. It is important to consult with local authorities to ensure that all applicable requirements are met. Local codes may have more stringent requirements than the NEC, or they may have specific requirements for certain types of installations. Failure to comply with local codes can result in fines or other penalties. When working with PVC conduit, it is important to follow all safety precautions. PVC conduit is a non-conductive material, but it can still pose a safety hazard if it is not handled properly. Eye protection should always be worn when cutting or bending PVC conduit to prevent debris from entering the eyes. Respiratory protection should also be worn when cutting or sanding PVC conduit to avoid inhaling dust particles. Gloves should be worn to protect the hands from cuts and abrasions. When using PVC solvent cement, it is important to work in a well-ventilated area to avoid inhaling the fumes. The cement is flammable and should be kept away from open flames and other sources of ignition. In addition to safety precautions, it is also important to use the correct tools and equipment when working with PVC conduit. A sharp saw or conduit cutter should be used to cut the conduit to the desired length. A PVC bender should be used to bend the conduit to the desired angle. A PVC solvent cement applicator should be used to apply the cement to the conduit fittings. Using the correct tools will help to ensure a safe and efficient installation. When supporting PVC conduit, it is important to use appropriate supports that are designed for use with PVC. These supports should be spaced according to the NEC requirements to prevent sagging or deformation of the conduit. The support should be securely fastened to the building structure to ensure that the conduit is properly supported. When installing PVC conduit underground, it is important to bury it at the proper depth to protect it from damage. The NEC specifies the minimum burial depth for PVC conduit based on the type of installation and the location. The conduit should be buried deep enough to protect it from frost heave, traffic loads, and other potential hazards. In addition to the burial depth, it is also important to provide proper backfill around the conduit. The backfill should be free of rocks, debris, and other sharp objects that could damage the conduit. The backfill should be compacted to provide support for the conduit and to prevent settling. When installing PVC conduit in wet locations, it is important to use watertight fittings and connectors. These fittings are designed to prevent moisture from entering the conduit and damaging the conductors. The fittings should be installed according to the manufacturer's instructions to ensure a watertight seal. In addition to watertight fittings, it is also important to seal the ends of the conduit to prevent moisture from entering. This can be done using duct seal or other approved sealant. The sealant should be applied liberally to ensure a complete seal. When installing PVC conduit in hazardous locations, it is important to use explosion-proof fittings and connectors. These fittings are designed to contain any explosion that may occur within the conduit system. The fittings should be installed according to the manufacturer's instructions to ensure an explosion-proof seal. In addition to explosion-proof fittings, it is also important to use explosion-proof conduit. This type of conduit is designed to withstand the pressure of an explosion and to prevent the propagation of flames. The conduit should be installed according to the manufacturer's instructions to ensure an explosion-proof system. Finally, when installing PVC conduit, it is important to inspect the installation to ensure that it is code compliant and that it meets all applicable requirements. The inspection should be performed by a qualified electrical inspector. The inspector will check the conduit for proper support, proper burial depth, proper fittings, and proper wiring. The inspector will also check the grounding system to ensure that it is properly installed. If the installation passes inspection, the inspector will issue a certificate of compliance. This certificate is required for many types of electrical installations. In conclusion, selecting and installing PVC conduit requires careful consideration of the application, the environmental conditions, and the applicable codes and regulations. By following the guidelines outlined in this overview, you can ensure a safe and code-compliant installation.